So section 3.3, day 2, we get into designing experiments. It adds more to what we did yesterday in 3.3, day 1. So the question we're going to answer today is, how do you design an experiment? So some discussion. We often look at two different ways of designing an experiment. We look at treatment and then observation. So here's a clear example. Right now, COVID is going on, right? And there's a bunch of pharmacies and places trying to come up with a vaccine. So they're coming up with a vaccine, which would be a treatment, and then they're testing it and they're observing how it works. So then whichever treatment works, whichever one they see works, whether it be on like animals or whatever they tested on cells, if they observe that it works and it passes all the tests, then that treatment will be used with people. So treatment, and then they observe how it works. So the treatment could be like a vaccine. Another way would be observe. I'll put observe 1. Then you give a treatment. Then you do a second observation. So then you observe 2. So observe 1 means first observation, observe 2 means a second. So you see how things are going, you observe, you give a treatment, and then you observe again. Okay? So there's a couple ways you can set these up. So it says, unfortunately, when experiments are conducted on people in the real world, they can often produce worthless data because of things like the placebo effect. The placebo effect, if you haven't heard, it's a belief that a procedure will cause you to change when in fact nothing was done to you and your belief is the only thing that changed. So it's like you take Tylenol. You have a headache, right? You take Tylenol and all of a sudden you feel better. There had to be studies done to say like maybe you just thought you felt better because you took Tylenol. This is also known as the dummy effect. Right? People often create a placebo effect when a new treatment comes out because they want it to work. So, for example, like if 2 people have a headache, right? And you have 2 pills. One could be a sugar pill, one could be an actual like aspirin or Tylenol. Studies had to be done to show that the people who take the aspirin feel better or have more relief with their headache than people who take the sugar pill. Because otherwise, it would not prove that the Tylenol is actually better. It would just show that you took a pill so you made yourself think you feel better. So that would be placebo effect. The control group is the group of patients who receive a fake treatment. So this is the group you're controlling to measure the amount of the placebo effect. So it could be like if you had, let's say like in your weight training class, there's 50 people in there and you want to do a study on steroids. Okay, might not be the best example, but let's say that you have a pill for everyone and you give everyone steroids except you're taking 5 people and you're giving them a sugar pill. And you're going to see how does their body get affected that's different than those that took the steroids. Okay, so the control group is a group that you specifically just give like a sugar pill. And there are 3 basic principles. There is control. You impose multiple treatments to control the effects of other variables in the treatment and the response. So you want to make sure that you're focusing just on what you want to and there's not other things affecting it. It's kind of like if you want to try to see what makes a tree grow faster, you want to make sure that there's not other things affecting the tree's growth, just what you're giving it. Okay, there's randomization.
I have a question.
Right. So randomization is when you create groups for the treatment randomly. So you can't like, if you're doing a steroids test, that way you can't like pick the biggest, strongest guys. You have to randomly pick people. And then replication. That means each treatment must be conducted in a similar way on many subjects to reduce the chance variation in the results. So you can't just like do a study one time with one person and say, okay, it works. You have to repeat it many times and to conclude on something. You can't just do it with the same person over and over again. You need multiple subjects to really show that that study is true or that study works. So in example 1, it says, this is from the last lesson, an experiment using 36 undergrad students. They viewed a 40-minute long television program that included ads from a product. Some people saw 30-second commercials while others saw 90-second commercials. The same commercials were run differing number of times during the show. So some people saw it 1 time, some saw it 3 times, some saw it 5 times. And after viewing, all of the people answered questions about their recall of the ad and their attitude towards the product, whether they consider buying it or not. So people are seeing the ad a different number of times, and some people are seeing longer commercials than others. So how many treatments are there? Let's take a look. There are going to be 6 treatments. If you remember from the last note section, there's that table of 6. In order to be fair in our comparisons, you need to create 6 randomly selected groups. Okay, so 6 simple random samples. So the size of the group has to be the same. So you take the number in the sample divided by the number of treatments. So there are 36 people, excuse me, 36 people in the sample, and there are 6 treatments. So this case would be 36 divided by 6. So there would be 6 people getting each treatment. So the 36 students are randomly assigned. Group 1 would have 6 students or 6 subjects. Group 2 would have 6 subjects. So group 3 and group 4, group 5 and group 6. Okay, so they all would have 6 subjects. All right, and then treatment 1 would be 30 seconds and they see it 1 time. Treatment 2 will be 30 seconds and they see it 3 times. Treatment 3 is 30 seconds, they see it 5 times. Treatment 4 is 90 seconds, they see it 1 time. Treatment 5 is 90 seconds 3 times, and then treatment 6 is they see a 90-second commercial 5 different times. So depending on where you randomly get assigned, you would see one of those amounts. Like one of you might actually get assigned and see the 90-second commercial 5 times. Someone else might just see a 30-second commercial 1 time. Okay, and then at the end, you would observe the effects. Observe effects on recall and attitude to buying. So like the 30-second commercial 1 time, you might not recall anything about it. You might not even remember seeing the commercial. But if you saw a 90-second commercial 5 times, you might get so upset and frustrated and just say, I'm never gonna buy that thing because you're mad about seeing the commercial over and over and over again. So I think we've all seen commercials where we get annoyed by it and we just get ticked, so that could have the same effect. So it says, let's take our subjects 01 through 36, okay, and randomly place them in 6 groups. Start with line 145. Okay, so group 1, if you go to line 145 will be from your simple random digit table. If you look at line 145, the first numbers on 145 are 19. So 19 would be the first one picked. After 19, it's 68. 68's too big because it only goes up to 36. After 68 is 71. That's also too big. And then we have 26. All right, after 26 is 33. 33 works. After 33 is 57. That's too big. Then 85 is too big. 79, then 58, but then we have 06. And if you keep going, after 06 is 09. And then after 09 is 93. That's too big. And then we have 10. So those would be the first 6 people picked to go in group 1. And then the other groups are picked for us there. So we see the other groups. We're not going to do all of these, but if you did the experiment, you would have to use the random digit chart and you'd have to assign 6 people in 6 groups. So this example represents a completely randomized design. That means when all the experimental units are allocated at random, so they're all allocated at random among all the treatments. So you're randomly selected to all the treatments. Okay, in number 2, we're actually going to draw this out. So they say an electric company wants to determine the best way to convince its customers to conserve energy. One method would be to visit each home in the sample, and there are 60 homes, with an indicator to show that the cost would be if the electricity use at that moment continued for a month. The other method would be to provide information in a chart so people could track their own electricity use. So one group, let me get a highlighter. An indicator would show what the cost would be if it continued for the rest of the month like what they had. And the other one would be provide a chart so people could track their own electricity. And then a control group is to be used in this experiment. Okay, so the control group, different color. The control group would be the group that is not getting either. We want to show our random experiment. We would start with 60 homes. Okay, there are 3 different things they could receive. There's 1, 2, 3 different treatments. And these are all randomly assigned. I'm going to put RA for randomly assigned. There is group 1, group 2, and there's group 3. So there are 3 groups, so 3 treatments, and there are 60 homes. How many would be in each group? So there are 60 homes, that would be 20, 20, and 20. Right, because you want to even. You don't want to have 40 and then 10. You want 20, 20, and 20, an even group. Okay? Group 1 will receive treatment 1. Treatment 1 will be the indicator, which is highlighted in red. That means someone will come to their house, they'll see what lights and stuff are on, and they'll say, okay, if you ran your lights like this for a whole month, this is what it would cost. Group 2 will receive treatment 2, which will be the info chart. So put info/chart. And then group 3 will receive treatment 3. These will be the control, which means they do not receive any information or indicator. And then in the end, we will compare electricity use. So we want to see what is the most effective. Is it more effective to give them the indicator? Is it more effective to give them the chart? Or were neither one effective? So like that control group is just to show like, hey, neither one of these were good because people that didn't get either control were the best, right? So if this group is better than these 2, that means those other 2 were not effective. All right, so explain the above design in a short paragraph. I'll just write a quick little summary. You'd say we start with 60 homes. We randomly assign them to 3 groups. I should actually write this out. Randomly assign them 2 groups of 20, each group gets a different treatment. Okay, and then we compare to see which treatment has best effect on electricity use. So that's basically the same we did. We took the 60 homes, assigned them the groups of 20. Each one had a different treatment. The treatment would have been indicator, control, or chart. And then we compared to see which treatment was the best effect on electricity use. All right, and that's how we can design an experiment.